Hi, my name is Christopher Pavlovich. This is my final write-up on Spectre. So what is Spectre? So speculative execution implementations that exploit a blind spot in security. This currently affects all the three major CPU providers, Intel, AMD, and ARM. The Spectre attacks are a series of programs which are designed to exploit this vulnerability, which is the blind spot, typically the L1, 2, or 3 cache in the CPU. The current or latest vulnerability is called branch history injection, which is the evolved form of branch target injection, which has already been patched. Variant 1 uses conditional branch exploit, variant 2 uses indirect branch exploit. It's important to note that Spectre is not Meltdown, two separate vulnerabilities, but they are both architecture related, as you can see here. Meltdown is a series of related microarchitectural attacks exploiting out-of-order execution to leak kernel memory. Two key differences include that Meltdown has no branch prediction. Meltdown relies on the observation of what an instruction causes a trap. The following instructions are executed out of order before being terminated. So essentially, instructions that would come later can be bumped up in the queue and executed before predecessing processes. So Meltdown exploits a vulnerability specific to many Intel and some ARM processors, which allows certain speculative executed instructions to bypass memory protection, allowing them to be read by the user, or the attacker in this case. Spectre, in contrast, works on far more CPUs, including some created by AMD. The Kaiser mechanism protects against Meltdown, but it does not protect against Spectre. And this is one of the patches they've done on Intel CPUs. So how it works. Spectre determines information about the execution environment. We'll get a little more into the specifics later, but the software finds the hypervisor ASLR location, and that's the address space layout randomization. This is done by analyzing branch history buffers, or branch target buffer leaks. It also finds L3 cache set association information and physical memory maps, and their location using a Spectre gadget executing via branch target injection. It's important to note that branch target injection is Spectre v2, which has been patched. Branch history injection is what's used in this latest vulnerability discovered, I think, in May. This leaks hypervisor memory from the attacker chosen addresses by executing the eBPF interpreter in hypervisor memory as a Spectre gadget. This is known as indirect branch poisoning, and it's been adapted from v2 to v3 or BHB branch history. So I found a cool YouTube demo. I could not include a video easily into this, so I grabbed some key screenshots of the most important stages so you can see the latest version as it runs on a 10th gen Intel processor. So you can see in figure 2, which is the first step, it gets the kernel version and CPU model, and it checks which patches have been applied to that CPU. So you can see it has already patched Spectre version 2. Yet this exploit still works. You see protection against, that's branch target injection, but not branch history injection. So figure 3 shows that we invoke the password command, which if you're familiar with Linux, that's how you change and edit passwords, including the root account password, which and all that information securely stored in etc shadow. So that loads shadow into memory, which then we build an eviction set to determine the memory region. On the next slide, you'll see that we actually start to break that down and read the memory. So in figure 4, it's a lengthy process. It says 8 minutes here for V2 demos. Other demos I've seen, I didn't see fully in a clean video like this, so I didn't include screenshots, but from some of the other sources I provided, this can take up to 40 minutes to crack in to the actual memory itself. So this is based on a memory map preset by a designated memory region. Tests have been run on multiple region sizes in this program execution to determine the precise memory region of this hardware, which tells them exactly where to look for memory to be leaked. See the source code on GitHub. It's provided in the YouTube comments for this video. If you look at the branch We're Excited page, you'll see the YouTube video link. You can go to it from there. In figure 5, we see the root password is parsed out of the etc shadow memory content. The script does it all for you, pulls out the root password and prints it right to the screen so you can copy and paste, giving the attacker full access to the system. So this is an alternate demo from a version 2 source. So that last demo we looked at was BHB, branch history injection. So this is actually using branch target injection, so it's slightly different, but it is still a Spectre vulnerability. This is provided by SpectreAttack.com, which is written by a large number of scholarly people who know a lot about the topic. So you can see that first it determines the size of a desired memory region, just like BHB. It makes sure the region is valid by trying to write to it and making sure that something actually holds in memory. It then reads secure memory from the pre-designated region and reports back to the terminal with success failure messages, along with the value, which is the contents of our not so secure memory region, which in this case is most likely the L3 cache based on the paper that documents this code. Here's my works cited. The most informative paper, it's about a 20 to 40 page, depending on how you look at all the included citations, is the one with Paul Kosher here at the beginning. SpectreAttack.com is a fantastic resource that actually provides a couple different demos that you can try yourself. The images were taken from the Spectre Flies Back. It's a fun article that just describes some implications of this software. And the first here on the works cited is the YouTube video that I found awesome. It's only a minute long. If you haven't seen this exploit yourself, it's worth giving it a watch. And if you look down in the comments, there's a link to their website, which has a couple different papers on both Spectre and Meltdown and some of the differences in how those are implemented. Thank you for watching.